Hello and welcome. Today I eventually get around to answering Asante's question on capacitance quiz 2. Okay, so here we see that there's a capacitor in a circuit. The voltage is 8 volts. Now if we go to question B that Asante requested, they asked for, okay, some capacitors, each is a 4,500 microfarad with a maximum voltage of 6 volts. So we don't have to use all the volts. They just can't go over 6 volts are available. Draw an arrangement of these capacitors that would provide a total capacitance of 4,500 microfarad for the use in the circuit above. So if we think about it, we've got a voltage of 8 volts. Okay, if I just put a single capacitor in there of 4,500 microfarad, it's got too much voltage. Okay, so then this capacitor is going to blow. So if I add another capacitor in series, now each one receives 4 volts. Okay, but what happens to my total capacitance? It's 1 over 4,500 plus 1 over 4,500, which gives me 2,250 microfarad as my total capacitance. So they want us to lower the voltage but still get a total capacitance of 4,500. So we're not there yet. But if we add another set like this, each branch is 2,250. So 2,250 microfarad plus 2,250 microfarad gives me 4,500 microfarads. The question is, what's the voltage? So the voltage of 8 volts is shared in each branch. Okay, so this branch has 8 volts, so that branch has 8 volts, leaving each capacitor with 4 volts, and therefore we have solved the problem. Total capacitance of 4,500 microfarad, but each capacitor may not exceed 6 volts. In question 4, they tell us we've got 48 microfarad capacitors working at a voltage of 25 volts. So that's the maximum safe voltage. Show how a number of these capacitors may be connected to provide a capacitor of capacitance 48 microfarad, so a total of 48, but they must be safe to be working with 50 volts. So we have 50 volts, but our capacitors can only take 25. But we still want a total capacitance of 48. So if I put a 48 and a 48 next to each other, the total capacitance is 24, but each of them uses 25 volts. So we've covered the 50 volts, but we haven't covered the total capacitance. Okay, so the total capacitance for this branch would be 24 microfarad, because we add those two 48s in parallel. So we want a total capacitance of 48, so if we add another 2 in parallel to those two, okay, each of them receives 25 and 25. This branch is 24 microfarad, that branch is 24 microfarad, and since we add in parallel, it becomes 48 microfarad. In part B to this question, they tell us that we want 72 microfarad as a total capacitance, and our safe working voltage is 25. So we have our 25 in our cells. Okay, so 25 here, but we want a total working of 72. Okay, so now we saw that one of them has 48 and it takes 25. So that's 48 here. Okay. If we add another one, 48 and 48 is going to be 96, which is too much. But still, each one is only receiving 25, so they won't blow. So what I do is I add another one here, and now I have a 48 and a total capacitance of 24. So 48 and 48 divided by 2, if we use the equation. So if we add that together, the total capacitance is then 72 microfarad. This one receives 25, this one receives 12.5 volts and 12.5 volts, and nobody has exceeded the 25 volts limit. I hope you understand, and if you still have questions, please let me know.